Chapter 6. The 12th Planet. The suggestion that Earth was visited by intelligent beings from elsewhere postulates the existence of another celestial body upon which intelligent beings established a civilization more advanced than ours. Speculation regarding the possibility of Earth visitation by intelligent beings from elsewhere has centered, in the past, on such planets as Mars or Venus as their place of origin. However, now that it is virtually certain that these two planetary neighbors of Earth have neither intelligent life nor an advanced civilization upon them, those who believe in such Earth visitations look to other galaxies and to distant stars as the home of such extraterrestrial astronauts. The advantage of such suggestions is that while they cannot be proved, they cannot be disproved either. The disadvantage is that these suggested, quote, homes, end quote, are fantastically distant from Earth, requiring years upon years of travel at the speed of light. The authors of such suggestions therefore postulate one-way trips to Earth, a team of astronauts on a no-return mission, or perhaps on a spaceship lost and out of control, crash landing upon Earth. This is definitely not the Sumerian notion of the heavenly abode of the gods. The Sumerians accepted the existence of such a, quote, heavenly abode, end quote, a, quote, pure place, end quote, a, quote, primeval abode, end quote. While Enlil, Enki, and Ninhursag went to Earth and made their home upon it, their father Anu remained in the heavenly abode as its ruler. Not only occasional references in various texts, but also detailed, quote, god lists, end quote, actually named 21 divine couples of the dynasty that preceded Anu on the throne of the, quote, pure place, end quote. Anu himself reigned over a court of great splendor and extent. As Gilgamesh reported, and the book of Ezekiel confirmed, it was a place with an artificial garden sculpted wholly of semi-precious stones. There, Anu resided with his official consort Antu and 6 concubines, 80 offspring, of which 14 were by Antu, 1 prime minister, 3 commanders in charge of the Muse, rocket ships, 2 commanders of the weapons, 2 great masters of written knowledge, 1 minister of the purse, 2 chief justices, 2, quote, who with sound impress, end quote, and 2 chief scribes with 5 assistant scribes. Mesopotamian texts refer frequently to the magnificence of the abode of Anu and the gods and weapons that guarded its gateway. The tale of Adapa reports that the god Enki, having provided Adapa with a Shem, made him take the road to heaven, and to heaven he went up. When he had ascended to heaven, he approached the gate of Anu. Tammuz and Gizida were standing guard at the gate of Anu. Guarded by the divine weapons Sharur, quote, royal hunter, end quote, and Shargaz, quote, royal killer, end quote, the throne room of Anu was the place of assembly of the gods. On such occasions, a strict protocol governed the order of entering and seating. Enlil enters the throne room of Anu, seats himself at the right place of the right tiara. On the right of Anu, Ea enters, the throne room of Anu, seats himself at the place of the sacred tiara on the left of Anu. The gods of heaven and earth of the ancient Near East not only originated in the heavens, but could also return to the heavenly abode. Anu occasionally came down to earth on state visits. Ishtar went up to Anu at least twice. Enlil's center in Nippur was equipped as a, quote, bond heaven-earth, end quote. Shamash was in charge of the eagles and the launching place of the rocket ships. Gilgamesh went up to the place of eternity and returned to Uruk. Adapa too made the trip and came back to tell about it. So did the biblical king of Tyre. A number of Mesopotamian texts deal with the Apkallu, an Akkadian term stemming from the Sumerian Abgal, quote, great one who leads, end quote, or, quote, master who points the way, end quote. A study by Gustav Guterbach of Die historische Tradition und ihr literarische Gestaltung bei Babylonier und Hittiten ascertained that these were the, quote, birdmen, end quote, depicted as the, quote, eagles, end quote, that we have already shown. The text that spoke of their feet said of one that he, quote, brought down Inanna from heaven to the Eanna temple made her descend, end quote. This and other references indicate that these 𝐓𝐘𝐒 were the pilots of the spaceships of the Nephilim. Two-way travel was not only possible, but actually contemplated to begin with, for we are told that, having decided to establish in Sumer the gateway of the gods, or Babili, the leader of the gods explained, "When to the primeval source, for assembly you shall ascend. There shall be a rest place for the night, to receive you all. When from the heavens for assembly you shall descend, there shall be a rest place for the night, to receive you all." Realizing that such two-way travel between earth and the heavenly abode was both contemplated and practiced, the people of Sumer did not exile their gods to distant galaxies. The abode of the gods, their legacy discloses, was within our own solar system. We have seen Shamash in his official uniform as commander of the Eagles. On each of his wrists he wears a watch-like object held in place by metal clasps. Other depictions of the eagles reveal that all the important ones wore such objects. Whether they were merely decorative or served a useful purpose, we do not know. But all scholars are agreed that the objects represented rosettes, a circular cluster of, quote, petals, end quote, radiating from a central point. The rosette was the most common decorative temple symbol throughout the ancient land, prevalent in Mesopotamia, Western Asia, Anatolia, Cyprus, Crete, and Greece. It is the accepted view that the rosette as a temple symbol was an outgrowth or stylization of a celestial phenomenon, a sun encircled by its satellites. That the ancient astronauts wore this symbol on their wrists adds credence to this view. An Assyrian depiction of the gateway of Anu and the heavenly abode confirms ancient familiarity with a celestial system such as our sun and its planets. The gateway is flanked by two eagles, indicating that their services are needed to reach the heavenly abode. The winged globe, the supreme divine emblem, marks the gateway. It is flanked by the celestial symbols of the number 7 and the crescent, representing, we believe, Anu flanked by Enlil and Enki. Where are the celestial bodies represented by these symbols? Where is the heavenly abode? The ancient artist answers with yet another depiction, that of a large celestial deity extending its rays to 11 smaller celestial bodies encircling it. It is a representation of a sun orbited by 11 planets. That this was not an isolated representation can be shown by reproducing other depictions on cylinder seals, like this one from the Berlin Museum of the Ancient Near East. When the central god or celestial body in the Berlin seal is enlarged, we can see that it depicts a large, ray-emitting star surrounded by 11 heavenly bodies, planets. These, in turn, rest on a chain of 24 smaller globes. Is it a coincidence that the number of all the, quote, moons, end quote, or satellites of the planets in our solar system, astronomers exclude those of 10 miles or less in diameter, is also exactly 24? Now there is, of course, a catch to claiming these depictions. Of a sun and 11 planets represent our solar system, for our scholars tell us that the planetary system of which Earth is a part comprises of the Sun, Earth and Moon, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. This adds up to the Sun and only 10 planets, when the Moon is counted as one. But that is not what the Sumerians said. They claimed that our solar system was made up of the Sun and 11 planets, counting the Moon, and held steadfastly to the opinion that, in addition to the planets known to us today, there has been a 12th member of the solar system, the home planet of the Nephilim. We shall call it the 12th planet. Before we check the accuracy of the Sumerian information, let us review the history of our own knowledge of Earth and the heavens around it. We know today that beyond the giant planets Jupiter and Saturn, at distances insignificant in terms of the universe, but immense in human terms, two more major planets, Uranus and Neptune, and a third, small one, Pluto, belong to our solar system. But such knowledge is quite recent. Uranus was discovered through the use of improved telescopes in 1781. After observing it for some 50 years, some astronomers reached the conclusion that its orbit revealed the influence of yet another planet. Guided by such mathematical calculations, the missing planet, named Neptune, was pinpointed by astronomers in 1846. Then, by the end of the 19th century, it became evident that Neptune itself was being subjected to unknown gravitational pull. Was there yet another planet in our solar system? The puzzle was solved in 1930 with the observation and location of Pluto. Up to 1780 then, and for centuries before that, people believed that there were 7 members of our solar system: Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. Earth was not counted as a planet because it was believed that these other celestial bodies circled Earth, the most important celestial body created by God, with God's most important creation, man, upon it. Our textbooks generally credit Nicholas Copernicus with the discovery that Earth is only one of several planets in a heliocentric, sun-centered system. Fearing the wrath of the Christian Church for challenging Earth's central position, Copernicus published his study, De Revolutionibus Orbium Coelestium, only when on his deathbed in 1543. Spurred to re-examine centuries-old astronomical concepts primarily by the navigational needs of the Age of Discovery and by the findings of Columbus in 1492, Magellan in 1520, and others that Earth was not flat but spherical, Copernicus depended on mathematical calculations and searched for the answers in ancient writings. One of the few churchmen who supported Copernicus, Cardinal Schonberg, wrote to him in 1536, quote, "I have learned that you know not only the groundwork of the ancient mathematical doctrines, but that you have created a new theory, according to which the earth is in motion and it is the sun which occupies the fundamental and therefore the cardinal position." End quote. The concepts then held were based on Greek and Roman traditions that Earth, which was flat, was, quote, vaulted over, end quote, by the distant heavens, in which the stars were fixed. Against the star-studded heavens, the planets, from the Greek word for, quote, wanderer, end quote, moved around Earth. There were thus 7 celestial bodies, from which the 7 days of the week and their names originated: the Sun, Sunday; Moon, Monday; Mars, Mardi; Mercury, Mercredi; Jupiter, Jude; Venus, Vendredi; Saturn, Saturday. These astronomical notions stem from the works and codifications of Ptolemy, an astronomer in the city of Alexandria, Egypt, in the 2nd century A.D. His definite findings were that the Sun, Moon, and 5 planets moved in circles around Earth. The Ptolemaic astronomy predominated for more than 1,300 years, until Copernicus put the sun in the center. While some have called Copernicus the, quote, father of modern astronomy, end quote, others view him more as a researcher and reconstructor of earlier ideas. The fact is that he pored over the writings of Greek astronomers who preceded Ptolemy, such as Hipparchus and Aristarchus of Samos. The latter suggested in the 3rd century BC that the motions of the heavenly bodies could be explained in the sun, and not Earth, were assumed to be in the center. In fact, 2,000 years before Copernicus, Greek astronomers listed the planets in their correct order from the sun, acknowledging thereby that the sun, not Earth, was the solar system's focal point. The heliocentric concept was only rediscovered by Copernicus, and the interesting fact is that astronomers knew more in 500 BC than in AD 500 and 1500. Indeed, scholars are now hard put to explain why first the later Greeks and then the Romans assumed that Earth was flat, rising above a layer of murky waters below which there lay Hades or, quote, hell, end quote, when some of the evidence left by Greek astronomers from the earlier times indicates that they knew otherwise. Hipparchus, who lived in Asia Minor in the 2nd century BC, discussed, quote, the displacement of the solstitial and equinoctial sign, end quote, the phenomenon now called precession of the equinoxes. But the phenomenon can be explained only in terms of a, quote, spherical astronomy, end quote, whereby Earth is surrounded by the other celestial bodies as a sphere within a spherical universe. Did Hipparchus then know that Earth was a globe, and did he make his calculations in terms of a spherical astronomy? Equally important is yet another question. The phenomenon of the precession could be observed by relating the arrival of spring to the sun's position, as seen from Earth, in a given zodiacal constellation. But the shift from one zodiacal house to another requires 2,160 years. Hipparchus certainly could not have lived long enough to make that astronomical observation. Where, then, did he obtain this information? Eudoxus of Cnidus, another Greek mathematician and astronomer who lived in Asia Minor 2 centuries before Hipparchus, designed a celestial sphere, a copy of which was set up in Rome as a statue of Atlas supporting the world. The designs on the sphere represented the zodiacal constellations, but if Eudoxus conceived the heavens as a sphere, where in relation to the heavens was Earth? Did he think that the celestial globe rested on a flat Earth, a most awkward arrangement, or did he know of a spherical Earth enveloped by a celestial sphere? The works of Eudoxus, lost in their originals, have come down to us thanks to the poems of Aratus, who in the 3rd century BC, quote, translated, end quote, the facts put forth by the astronomer in poetic language. In this poem, which must have been familiar to St. Paul, who quoted from it, the constellations are described in great detail, quote, drawn all around, end quote, and their grouping and naming is ascribed to a very remote prior age. Quote, some men of yore a nomenclature thought of and devised, and appropriate forms found, end quote. Who were the, quote, men of yore, end quote, to whom Eudoxus attributed the designation of these constellations? Based on certain clues in the poem, modern astronomers believe that the Greek verses describe the heavens as they were observed in Mesopotamia circa 2200 BC. The fact that both Hipparchus and Eudoxus lived in Asia Minor raises the probability that they drew their knowledge from Hittite sources. Perhaps they even visited the Hittite capital and viewed the divine procession carved on the rocks there, for among the marching gods, 2 bullmen hold up a globe, a sight that might well have inspired Eudoxus to sculpt Atlas and the celestial sphere. Were the earlier Greek astronomers living in Asia Minor better informed than their successors because they could draw on Mesopotamian sources? Hipparchus, in fact, confirmed in his writings that his studies were based on knowledge accumulated and verified over many millennia. He named as his mentors, quote, Babylonian astronomers of Erech, Borsippa, and Babylon, end quote. Geminus of Rhodes named the, quote, Chaldeans, end quote, the ancient Babylonians, as their discoverers of the exact motions of the moon. The historian Diodorus Siculus, writing in the 1st century BC, confirmed the exactness of Mesopotamian astronomy. He stated that, quote, the Chaldeans named the planets, and the center of their system was the sun, the greatest light, of which the planets were offspring, reflecting the sun's position and shine, end quote. The acknowledged source of Greek astronomical knowledge was then Chaldea. Invariably, those earlier Chaldeans possessed greater and more accurate knowledge than the peoples that followed them. For generations throughout the ancient world, the name, quote, Chaldean, end quote, was synonymous with, quote, stargazers, end quote, astronomers. Abraham, who came out of, quote, Ur of the Chaldeans, end quote, was told by God to gaze at the stars when the future Hebrew generations were discussed. Indeed, the Old Testament was replete with astronomical information. Joseph compared himself and his brothers to 12 celestial bodies, and the patriarch Jacob blessed his 12 descendants by associating them with the 12 constellations of the zodiac. The Psalms and the book of Job refer repeatedly to celestial phenomena, the zodiacal constellations, and other star groups, such as the Pleiades. Knowledge of the zodiac, the scientific division of the heavens, and other astronomical information was thus prevalent in the ancient Near East well before the days of ancient Greece. The scope of Mesopotamian astronomy, on which the earlier Greek astronomers drew, must have been vast, for even what archaeologists have found amounts to an avalanche of texts, inscriptions, seal impressions, reliefs, drawings, lists of celestial bodies, omens, calendars, tables of rising and setting times of the sun and the planets, and forecasts of eclipses. Many such later texts were, to be sure, more astrological than astronomical in nature. The heavens and the movements of the heavenly bodies appeared to be a prime preoccupation of mighty kings, temple priests, and the people of the land in general. The purpose of the stargazing seemed to be to find in the heavens an answer to the course of affairs on earth: war, peace, abundance, famine. Compiling and analyzing hundreds of texts from the first millennium BC, R.C. Thompson of the reports of magicians and astrologers of Nineveh and Babylon was able to show that these stargazers were concerned with the fortunes of the land, its people, and its ruler from a national point of view, and not with individual fortunes, as present-day, quote, horoscopic, end quote, astrology is. When the moon in its calculated time is not seen, there will be an invasion of a mighty city. When a comet reaches the path of the sun, field flow will be diminished, and uproar will happen twice. When Jupiter goes with Venus, the prayers of the land will reach the heart of the gods. If the sun stands in the station of the moon, the king of the land will be secure on the throne. Even this astrology required comprehensive and accurate astronomical knowledge, without which no omens were possible. The Mesopotamians, possessing such knowledge, distinguished between the, quote, fixed, end quote, stars and the planets that, quote, wandered about, end quote, and knew that the sun and the moon were neither fixed stars nor ordinary planets. They were familiar with comets, meteors, and other celestial phenomena, and could calculate the relationships between the movement of the sun, moon, and earth, and predict eclipses. They followed the motions of the celestial bodies and related them to Earth's orbit and rotation through the heliacal system, the system still in use today, which measures the rising and setting of stars and planets in Earth's skies relative to the sun. To keep track of the movements of the celestial bodies and their positions in the heavens relative to Earth and to one another, the Babylonians and Assyrians kept accurate ephemerides. These were tables that listed and predicted the future positions of the celestial bodies. Professor George Sarton of Chaldean astronomy of the last 3 centuries BC found that they were computed by 2 methods, a later one used in Babylon and an older one from Uruk. His unexpected finding was that the older Uruk method was more sophisticated and more accurate than the later system. He accounted for this surprising situation by concluding that the erroneous astronomical notions of the Greeks and Romans resulted from a shift to a philosophy that explained the world in geometric terms, while the astronomer priests of Chaldea followed the prescribed formulas and traditions of Sumer. The unearthing of the Mesopotamian civilizations in the past 100 years leaves no doubt that in the field of astronomy, as in so many others, the roots of our knowledge lie deep in Mesopotamia. In this field, too, we draw upon and continue the heritage of Sumer. Sarton's conclusions have been reinforced by very comprehensive studies by Professor O. Neugebauer of Astronomical Cuneiform Text, who was astonished to find that the ephemerides, precise as they were not based on observations by the Babylonian astronomers who prepared them. Instead, they were calculated, quote, from some fixed arithmetical schemes, which were given and not to be interfered with, end quote, by the astronomers who used them. Such automatic adherence to, quote, arithmetical schemes, end quote, was achieved with the aid of, quote, procedure texts, end quote, that accompanied the ephemerides, which, quote, gave the rules for computing ephemerides step by step, end quote, according to some, quote, strict mathematical theory, end quote. Neugebauer concluded that the Babylonian astronomers were ignorant of these theories on which the ephemerides and their mathematical calculations were based. He also admitted that, quote, the empirical and theoretical foundation, end quote, of these accurate tables, to large extent, escapes modern scholars as well. Yet he is convinced that the ancient astronomical theories, quote, must have existed because it is impossible to devise computational schemes of high complication without a very elaborate plan, end quote. Professor Alfred Jeremias of Handbuch der Altorientalischen Geistkultur concluded that the Mesopotamian astronomers were acquainted with the phenomenon of retrograde, the apparent erratic and snake-like course of the planets as seen from Earth, caused by the fact that Earth orbits the Sun either faster or slower than the other planets. The significance of such knowledge lies not only in the fact that the retrograde is a phenomenon related to the orbits around the sun, but also in the fact that very long periods of observation were required to grasp and track it. Where were these complicated theories developed? And who made the observations without which they could not have been developed? 𝐓𝐘𝐒 pointed out that, quote, in the procedure text, we meet a great number of technical terms of wholly unknown reading, if not unknown meaning, end quote. Someone, much earlier than the Babylonians, possessed astronomical and mathematical knowledge far superior to that of later culture in Babylon, Assyria, Egypt, Greece, and Rome. The Babylonians and Assyrians devoted a substantial part of their astronomical efforts to keeping an accurate calendar. Like the Jewish calendar to this very day, it was a solar-lunar calendar, correlating, quote, interpolating, end quote, the solar year of just over 365 days with a lunar month of just under 30 days. While a calendar was important for business and other mundane needs, its accuracy was required primarily to determine the precise day and moment of the new year and other festivals and worship of the gods. To measure and correlate the intricate movements of sun, earth, moon, and planets, the Mesopotamian astronomer priests relied on a complex spherical astronomy. Earth was taken to be a sphere with an equator and poles. The heavens, too, were divided by imaginary equatorial and polar lines. The passage of celestial bodies was related to the ecliptic, the projection of the plane of Earth's orbit around the sun upon the celestial sphere. The equinoxes, or the points and the times at which the sun and its apparent annual movement north and south crosses the celestial equator. And the solstices, or the time when the sun during its apparent annual movement along the ecliptic is at its greatest declination north or south. All these are astronomical concepts used to this very day. But the Babylonians and Assyrians did not invent the calendar or the ingenious methods for its calculation. Their calendars, as well as our own, originated in Sumer. There, the scholars have found a calendar, in use from the very earliest times, that is the basis for all later calendars. The principal calendar and model was the calendar of Nippur, the seat and center of Enlil. Our present-day one is modeled on that Nippurian calendar. The Sumerians considered the new year to begin at the exact moment when the sun crossed the spring equinox. Professor Stephen Langdon of Tablets from the Archives of 𝐓𝐇𝐈𝐒, a ruler of Ur circa 2400 BC, show that Nippurian calendar selected a certain celestial body by whose settings against the sunset it was possible to determine the exact moment of the new year's arrival. This, he concluded, was done, quote, perhaps 2,000 years before the era of Dungi, end quote, that is, circa 4400 BC. Can it really be that the Sumerians, without actual instruments, nevertheless had the sophisticated astronomical and mathematical know-how required by a spherical astronomy and geometry? Indeed they had, as their language shows. They had a term, dub, that meant, in astronomy, the 360-degree, quote, circumference of the world, end quote, in relation to which they spoke of the curvature or arc of the heavens. For their astronomical and mathematical calculations, they drew an anur, an imagined, quote, heavenly horizon, end quote, against which they could measure the rising and setting of celestial bodies. Perpendicular to this horizon, they extended an imagined vertical line, the nubu sarda. With its aid, they obtained the zenith point and called it the anpa. They traced the lines we called meridians and called them, quote, the graded yokes, end quote. Latitude lines were called, quote, middle lines of heaven, end quote. The latitude line marking the summer solstice, for example, was called Anbil, or, quote, fiery point of the heavens, end quote. The Akkadian, Hurrian, Hittite, and other literary masterpieces of the ancient Near East, being translations or versions of Sumerian originals, were replete with Sumerian loanwords pertaining to celestial bodies and phenomena. Babylonian and Assyrian scholars who drew up star lists or wrote down calculations of planetary movements often noted the Sumerian originals on the tablets that they were copying or translating. The 25,000 texts devoted to astronomy and astrology said to have been included in the Nineveh library of Ashurbanipal frequently bore acknowledgments of Sumerian origins. a major astronomical series that the Babylonians called, quote, the Day of the Lord, end quote, was declared by its scribes to have been copied from a Sumerian tablet written in the time of Sargon of Akkad in the 3rd millennium BC. The tablet, dated to the 3rd dynasty of also in the 3rd millennium BC, describes and lists a series of celestial bodies so clearly that modern scholars had little difficulty in recognizing the text as a classification of constellations, among them Ursa Major, Draco, Lyra, Cygnus and Cepheus, and Triangulum in the northern skies, Orion, Canis Major, Hydra, Corvus, and Centaurus in the southern skies, and the familiar zodiacal constellations in the central celestial band. In ancient Mesopotamia, the secrets of celestial knowledge were guarded, studied, and transmitted by astronomer priests. It is thus perhaps fitting that 3 scholars who are credited with giving back to us the lost, quote, Chaldean, end quote, science were Jesuit priests: Joseph Epping, Johann Strassmann, and Franz X. Kugler. Kugler, in a masterwork of Sternkunde und Sterndienst in Babel, analyzed, deciphered, sorted out, and explained a vast number of texts and lists. In one instance, by mathematically, quote, turning the skies backwards, end quote, he was able to show that a list of 33 celestial bodies in the Babylonian skies of 1800 BC was neatly arranged according to present-day groupings. After much work deciding which are true groups and which are merely subgroups, the world's astronomical community agreed, in 1925, to divide the heavens as seen from Earth into 3 regions, northern, central, and southern, and group the stars therein into 88 constellations. As it turned out, there was nothing new in this arrangement, for the Sumerians were the first to divide the heavens into 3 bands or, quote, ways, end quote. The northern, quote, way, end quote, was named after Enlil, the southern after Ea, and the central band was, quote, the way of Anu, end quote, and to assign to them various constellations. The present-day central band, the band of the 12 constellations of the zodiac, corresponds exactly to the way of Anu, and which the Sumerians grouped the stars into 12 houses. In antiquity, as today, the phenomenon was related to the concept of the zodiac. The great circle of Earth around the sun was divided into 12 equal parts, of 30 degrees each. The stars seen in each of these segments, or, quote, houses, end quote, were grouped together in a constellation, each of which was then named according to the shape the stars of the group seemed to form. Because the constellations and their subdivisions, and even individual stars within the constellations, have reached Western civilization with names and descriptions borrowed heavily from Greek mythology, the Western world tended for nearly 2 millennia to credit the Greeks with this achievement. But it is now apparent that early Greek astronomers merely adopted into their language and mythology a ready-made astronomy obtained from the Sumerians. We have already noted how Hipparchus, Eudoxus, and others obtained their knowledge. Even Thales, the earliest Greek astronomer of consequence, who is said to have predicted the total solar eclipse of May 28, 585 BC, which stopped the war between the Lydians and the Medians, allowed that the sources of his knowledge were a pre-Semitic Mesopotamian origins, namely Sumerian. We have acquired the name, quote, zodiac, end quote, from the Greek zodiakos kyklos, quote, animal circle, end quote, because the layout of the star groups was likened to the shape of a lion, fishes, and so on. But those imaginary shapes and names were actually originated by the Sumerians, who called the 12 zodiacal constellations Ulhi, quote, shiny herd, end quote. 1. Guana, quote, heavenly bull, end quote, or Taurus. 2. Mashtaba, quote, twins, end quote, are Gemini. 3. Dove, quote, pincers, end quote, tongs, end quote, or the crab or Cancer. 4. Urgula, quote, lion, end quote, which we call Leo. 5. Absin, quote, her father was Sin, end quote, the maiden, Virgo. 6. Ziba Ana, quote, heavenly fate, end quote, the scales of Libra. 7. Gertab, quote, which claws and cuts, end quote, or Scorpio. 8. Pabil, quote, defender, end quote, also the archer, or Sagittarius. 9. Sahurmash, quote, goatfish, end quote, or Capricorn. 10. Gu, quote, Lord of the Waters, end quote, the water bearer, or Aquarius. 11. Simha, quote, fishes, end quote, or Pisces. And 12. Kumal, quote, field dweller, end quote, the ram, or Aries. The pictorial representations or signs of the zodiac, like their names, have remained virtually intact since their introduction in Sumer. Until the introduction of the telescope, European astronomers accepted the Ptolemaic recognition of only 19 constellations in the northern skies. By 1925, when the current classification was agreed upon, 28 constellations had been recognized in what the Sumerians called the Way of Enlil. We should no longer be surprised to find out that, unlike Ptolemy, the earlier Sumerians recognized, identified, grouped, named, and listed all the constellations of the northern skies. Of the celestial bodies in the Way of Enlil, 12 were deemed to be of Enlil, paralleling the 12 zodiacal celestial bodies in the Way of Anu. Likewise, in the southern portion of the skies, the Way of Ea, 12 constellations were listed, not merely as present in the southern skies, but as of the god Ea. In addition, these 12 principal constellations of Ea, several others were listed for their southern skies, though not so many are recognized today. The Way of Ea posed serious problems to the Assyriologists who undertook the immense task of unraveling the ancient astronomical knowledge, not only in terms of modern knowledge, but also based on what the sky should have looked like centuries and millennia ago. Observing the southern skies from Ur or Babylon, the Mesopotamian astronomers could see only a little more than halfway into the southern skies. The rest was already below the horizon. Yet, if correctly identified, some of the constellations of the Way of Ea lay well beyond the horizon. But there was an even greater problem. If, as the scholars assumed, the Mesopotamians believed, as the Greeks did in later times, that Earth was a mass of dry land resting upon a chaotic darkness of the netherworld, the Greek Hades, a flat disk over which the heavens arced in a semicircle, then there should have been no southern skies at all. Restricted by the assumption that the Mesopotamians were beholden to a flat Earth concept, modern scholars could not permit their conclusions to take them too much below the equatorial line dividing north and south. The evidence, however, shows that the 3 Sumerian, quote, ways, end quote, encompass the complete skies of the global, not flat, Earth. In 1900, T.G. Pinchas reported to the Royal Asiatic Society that he was able to reassemble and reconstruct a complete Mesopotamian astrolabe, literally, quote, taker of stars, end quote. He showed it to be a circular disk divided like a pie into 12 segments in 3 concentric rings, resulting in a field of 36 portions. The whole design had the appearance of a rosette of 12, quote, leaves, end quote, each of which had the name of a month written on it. Pinchas marked them 1 to 12 for convenience, starting with Nisanu, the first month of the Mesopotamian calendar. Each of the 36 portions also contained a name with a small circle below it, signifying that it was the name of a celestial body. The names have since been found in many texts and, quote, star lists, end quote, and are undoubtedly the names of constellations, stars, or planets. Each of the 36 segments also had a number written below the name of the celestial body. In the innermost ring, the numbers ranged from 30 to 60. In the central ring, from 60, written as, quote, 1, end quote, to 120. This, quote, 2, end quote, in the sexagesimal system meant 2 times 60, equaling 120. And in the outermost ring, from 120 to 240. What did these numbers represent? Writing nearly 50 years after the presentation by Pinchas, the astronomer and Assyriologist O. Neugebauer of History of Ancient Astronomy, Problems and Methods, could only say that, quote, the whole text constitutes some kind of schematic celestial map, In each of the 36 fields, we find the name of a constellation and simple numbers whose significance is not yet clear." End quote. A leading expert in the subject, B.L. van der Weerden, of Babylonian astronomy, the 36 stars, reflecting on the apparent rise and fall of the numbers in some rhythm, could only suggest that, quote, "the numbers have something to do with the duration of daylight," end quote. The puzzle can be solved, we believe, only if one discards the notion that the Mesopotamians believed in a flat earth, and recognizes that their astronomical knowledge was as good as ours, not because they had better instruments than we do, but because their source of information was the Nephilim. We suggest that the enigmatic numbers represent degrees of the celestial arc, with the North Pole as the starting point, and that the astrolabe was a planisphere, the representation of a sphere upon a flat surface. While the numbers increase and decrease, those in the opposite segments of the way of Enlil, such as Nisanu, 50, Teshritu, 40, add up to 90. All those for the way of Anu add up to 180, and all those for the way of Ea add up to 360, such as Nisanu 200, Teshritu 160. These figures are too familiar to be misunderstood. They represent segments of a complete spherical circumference. A quarter of the way, 90 degrees, halfway, 180 degrees, or a full circle, 360 degrees. The numbers given for the way of Enlil are so paired as to show that the Sumerian segment of the northern skies stretched over 60 degrees from the North Pole, bordering on the way of Anu at 30 degrees above the equator. The way of Anu was equidistant on both sides of the equator, reaching the 30 degrees south below the equator. Then, farther south and farthest away from the North Pole, lay the way of Ea, that part of Earth and the celestial globe that lay between 30 degrees south and the South Pole. The numbers in the way of Ea segments add up to 180 degrees in Adaru, February to March, and Ululu, August to September. The only point that is 180 degrees away from the North Pole, whether you go south on the east or on the west, is the South Pole, and this can hold true only if one deals with a sphere. Precession is the phenomenon caused by the wobble of the Earth's north-south axis, causing the North Pole, the one pointing at the North Star, and the South Pole to trace a grand circle in the heavens. The apparent retardation of Earth against the starry constellation amounts to about 50 seconds of an arc in 1 year, or 1 degree in 72 years. The grand circle, the time it takes the Earth's North Pole to point again at the same North Star, therefore lasts 25,920 years, 72 times 360. And that is what the astronomers call the Great Year or the Plutonian Year, for apparently Plato, too, was aware of the phenomenon. The rising and setting of various stars deemed significant in antiquity, and the precise determination of the spring equinox, which ushered in the new year, were related to the zodiacal house in which they occurred. Due to the celestial precession, the spring equinox and other celestial phenomenon, being retarded from year to year, were finally retarded once in 2,160 years by a full zodiacal house. Our astronomers continue to employ a, quote, 0 point, end quote, or, quote, the first point of Aries, end quote, which marked the spring equinox circa 900 BC. But this point has by now shifted well into the house of Pisces. Circa AD 2100, the spring equinox will begin to occur in the preceding house of Aquarius. This is what is meant by those who say that we are about to enter the age of Aquarius. Because the shift from one zodiacal house to another takes more than 2 millennia, scholars wonder how and where Hipparchus could have learned of the precision in the 2nd century BC. It is now clear that the source was Sumerian. Professor Langdon's findings reveal that the Nibiru calendar, established circa 4400 BC in the age of Taurus, reflects knowledge of the precession and the shift of the zodiacal houses that took place 2,160 years earlier than that. Professor Jeremias, who correlated Mesopotamian astronomical texts with Hittite astronomical texts, was also of the opinion that older astronomical tablets recorded the change from Taurus to Aries, and he concluded that the Mesopotamian astronomers predicted and anticipated the shift from Aries to Pisces. Subscribing to these conclusions, Professor Willie Hartner of the Earliest History of the Constellations in the Near East suggested that the Sumerians left behind plentiful pictorial evidence to the effect. When the spring equinox was in the zodiac of Taurus, the summer solstice occurred in the zodiac of Leo. Hartner drew attention to the recurrent motif of the bull-lion, quote, combat, end quote, appearing in Sumerian depictions from earliest times, and suggested that these motifs represent the key positions of the constellations of Taurus, the bull, and Leo, the lion, to an observer at 30 degrees north, such as at circa 4000 BC. Most scholars consider the Sumerian stress of Taurus as their first constellation as evidence not only of the antiquity of the zodiac, dating to circa 4000 BC, but also as testifying to the time when Sumerian civilization so suddenly began. Professor Jeremias, of the Old Testament and the Light of the Ancient East, found evidence showing that the Sumerian zodiacal chronological, quote, point zero, end quote, stood precisely between the bull and the twins. From this and other data, he concluded that the zodiac was devised in the age of Gemini, the twins. That is, even before Sumerian civilization began. The Sumerian tablet in the Berlin Museum, VAT 7847, begins the list of zodiacal constellations with that of Leo, taking us back to circa 11,000 BC, when man had just begun to till the land. Professor 𝐓𝐇𝐈𝐒 of the Babylonian expedition of the University of Pennsylvania went even farther. Studying thousands of tablets bearing mathematical tabulations, he concluded that, quote, all the multiplications and division tables from the temple libraries of Nippur and Sippar, and from the library of Ashurbanipal and Nineveh, were based upon the number 12,960,000, end quote. Analyzing this number and its significance, he concluded that it could be related only to the phenomenon of the precession, and that the Sumerians knew of the great year of 25,920 years. This is indeed fantastic astronomical sophistication at an impossible time. Just as it is evident that Sumerian astronomers possessed knowledge that they could not possibly have acquired on their own, so is there evidence to show that a good deal of their knowledge was of no practical use to them. This pertains not only to the very sophisticated astronomical methods that were used, who in ancient Sumer really needed to establish a celestial equator, for example, but also to a variety of elaborate texts that deal with the measurement of distances between stars. One of these texts, known as AO6478, lists the 26 major stars visible along the line we now call the Tropic of Cancer, and gives distances between them as measured in 3 different ways. The text first gives the distances between these stars by a unit called mana shukultu, quote, measured and weighed, end quote. It is believed that this was an ingenious device that related the weight of escaping water to the passage of time. It made possible the determination of distances between 2 stars in terms of time. The second column of distances was in terms of degrees of the arc of the skies. The full day, daylight and nighttime, was divided into 12 double hours. The arc of the heavens comprised a full circle of 360 degrees. Hence, 1 beru, or, quote, double hour, end quote, represented 30 degrees of the arc of the heavens. By this method, passage of time on Earth provided a measure of the distances in degrees between the named celestial bodies. The third method of measurement was beru and ashame, quote, length in the skies, end quote. F. Thoreau Danjon of Distances entre Atoles Fixus pointed out that while the first 2 methods were relative to the other phenomena, this third method provided absolute measurements. A, quote, celestial beru, end quote, he and others believe, was equivalent to 10,692 of our present-day meters, or 11,693 yards. The, quote, distances in the skies, end quote, between the 26 stars was calculated in the text as adding up to 655,200, quote, beru drawn in the skies, end quote. The availability of 3 different methods of measuring distances between stars conveys the great importance attached to the matter. Yet, who among the men and women of Sumer needed such knowledge? And who among them could devise the methods and accurately use them? The only possible answer is the Nephilim had the knowledge and the need for such accurate measurements. Capable of space travel, arriving on Earth from another planet, roaming Earth's skies, they were the only ones who could, and did, possess at the dawn of mankind's civilization the astronomical knowledge that required millennia to develop, the sophisticated methods in mathematics and concepts for an advanced astronomy, and the need to teach human scribes to copy and record meticulously table upon table of distances in the heavens, order of stars and groups of stars, heliacal risings and settings, a complex sun, moon, earth calendar, and the rest of the remarkable knowledge of both heaven and earth. Against this background, can it still be assumed that the Mesopotamian astronomers, guided by the Nephilim, were not aware of the planets beyond Saturn? That they did not know of Uranus, Neptune, and Pluto? Was their knowledge of Earth's own family, the solar system, less complete than that of distant stars, their order, and their distances? Astronomical information from ancient times contained in hundreds of detailed texts lists celestial bodies, neatly arranged by their celestial order, or by the gods, or the months, or the lands, or the constellations with which they were associated. One such text, analyzed by Ernest F. Widener of Handbuch der Babylonischen Astronomie, has come to be called, quote, the Great Star List, end quote. It listed in 5 columns 10 of celestial bodies as related to one another, to months, countries, and deities. Another text listed correctly the main stars in the zodiacal constellations. A text indexed as BM 86378, arranged, in its unbroken part, 71 celestial bodies by their locations in the heavens, and so on and on and on. In efforts to make sense of this legion of text, and in particular to identify correctly the planets of our solar system, a succession of scholars came up with confusing results. As we now know, their efforts were doomed to failure because they incorrectly assumed that Sumerians and their successors were unaware that the solar system was heliocentric, that Earth was but another planet, and that there were more planets beyond Saturn. Ignoring the possibility that some names in the star lists may have applied to Earth itself, and seeking to apply the great number of other names and epithets only to the 5 planets they believed were known to the Sumerians, scholars reached conflicting conclusions. Some scholars even suggested that the confusion was not theirs, but a Chaldean mix-up. For some unknown reason, they said, the Chaldeans had switched around the names of the 5, quote, known, end quote, planets. The Sumerians referred to all celestial bodies, planets, stars, or constellations, as mul, quote, who shine in the heights, end quote. The Akkadian term, 𝐓𝐘𝐒, was likewise applied by Babylonians and Assyrians as a general term for any celestial body. This practice further frustrated the scholars seeking to unravel the ancient astronomical text, but some muls that were termed lubad clearly designated planets of our solar system. Knowing that the Greek name for the planets was, quote, wanderers, end quote, the scholars have read lubad as, quote, wandering sheep, end quote, deriving from lu, quote, those which are shepherded, end quote, and bad, quote, high and afar, end quote. But now that we have shown that the Sumerians were fully aware of the true nature of the solar system, the other meanings of the term bad, quote, the olden, end quote, the foundation, end quote, or, quote, the one where death is, end quote, assume direct significance. These are appropriate epithets for the sun, and it follows that by lubad, the Sumerians meant not mere, quote, wandering sheep, end quote, but, quote, sheep, end quote, shepherded by the sun, the planets of our sun. The location and relation of the lubad to each other and to the sun were described in many Mesopotamian astronomical texts. There were references to those planets that are, quote, above, end quote, and those that are, quote, below, end quote. And Kugler correctly guessed that the reference point was Earth itself. But mostly the planets were spoken of in a framework of astronomical texts dealing with mulmul, a term that kept the scholars guessing. In the absence of a better solution, most scholars have agreed that the term mulmul stood for the Pleiades, a cluster of stars in the zodiacal constellation of Taurus, and the one through which the axis of the spring equinox passed, as viewed from Babylon, circa 2200 BC. Mesopotamian texts often indicate that the mulmul included 7 lumash, 7, quote, wanderers that are familiar, end quote. And the scholars assume that these were the brightest members of the Pleiades which can be seen with the naked eye. The fact that, depending on classification, the group has either 6 or 9 such bright stars, and not 7, posed a problem. But it was brushed aside for lack of any better ideas as to the meaning of mulmul.
Franz Kugler
of Sturkund und Sterndust in Babel reluctantly accepted the Pleiades as a solution, but expressed his astonishment when he found it stated unambiguously in Mesopotamian texts that mulmul included not only, quote, wanderers, end quote, planets, but also the sun and the moon, making it impossible to retain the Pleiades idea. He also came upon texts that clearly stated that, quote, mulmul ulshu 12, end quote, or, quote, mulmul is a band of 12, end quote, of which 10 formed a distinct group. We suggest that the term mulmul referred to the solar system, using the repetitive mulmul to indicate the group as a whole, as, quote, the celestial body comprising all celestial bodies, end quote. Charles Villeroy of 𝐓𝐷𝐼 Chaldean transliterated a Mesopotamian text, K3558, that describes the members of the mulmul or 𝐓𝐘𝐒/𝐘𝐒 group. The text's last line is explicit. 𝐘𝐒/𝐘𝐒, the number of its celestial bodies is 12. The stations of its celestial bodies 12. The complete months of the moon is 12. The text leaves no doubt. The mulmul, our solar system, was made up of 12 members. Perhaps this should not come as a surprise for the Greek scholars Diodorus explaining the 3, quote, ways, end quote, of the Chaldeans and the consequent listing of 36 celestial bodies, stated that, quote, of these celestial gods, 12 hold chief authority. To each of these the Chaldeans assign a month and a sign of the zodiac, end quote. Ernst Widener of Der Turkris und die Wedge in Himmel reported that in addition to the way of Anu and its 12 zodiacal constellations, some texts also referred to the, quote, way of the sun, end quote, which was also made up of 12 celestial bodies, the sun, the moon, and 10 others. Line 20 of the so-called Te tablet stated, quote, Nafar 12, Shermesh, Hala, Shah, Kakablu, Shah Sin U Shamash, Ina Libi Itiku, end quote. Which means, quote, all in all, 12 members where the moon and sun belong, where the planets orbit, end quote. We can now grasp the significance of the number 12 in the ancient world. The great circle of Sumerian gods, and of all Olympian gods thereafter, comprised exactly 12. Younger gods could join the circle only if older gods retired. Likewise, a vacancy had to be filled to retain the divine number. The principal celestial circle, the way of the sun with its 12 members, set the pattern, according to which each other celestial band was divided into 12 segments or was allocated 12 principal celestial bodies. Accordingly, there were 12 months in a year, 12 double hours in a day. Each division of Sumer was assigned 12 celestial bodies as a measure of good luck. Many studies, such as the one by S. Langdon of Babylonian genealogies and the Semitic calendar, show that the division of the year into 12 months was, from its very beginnings, related to the 12 great gods. Fritz Hammel of Die Astronomie der Alten Chaldeer and others after him have shown that the 12 months were closely connected with the 12 zodiacs and that both derived from 12 principal celestial bodies. Charles F. Jahn of Lexicologie Sumerienne reproduced a Sumerian list of 24 celestial bodies that paired 12 zodiacal constellations with 12 members of our solar system. In a long text identified by F. Thoreau Danjon of Rituales Akkadians as a temple program for the New Year festival in Babylon, the evidence for the consecration of 12 as a central celestial phenomenon is persuasive. The great temple, the 𝐓𝐔𝐘𝐒, had 12 gates. The powers of all celestial gods were vested in Marduk by reciting 12 times the pronouncement, quote, "My Lord, is he not my Lord?" End quote. The mercy of the god was then invoked 12 times, and that of his spouse 12 times. The total of 24 was then matched with the 12 zodiacal constellations and 12 members of the solar system. A boundary stone carved with the symbols of the celestial bodies by a king of Susa depicts those 24 signs. The familiar 12 signs of the zodiac, and symbols that stand for the 12 members of the solar system. These were the 12 astral gods of Mesopotamia, as well as of the Hurrian, Hittite, Greek, and all other ancient pantheons. Although our natural counting base is the number 10, the number 12 permeated all matters celestial and divine long after the Sumerians were gone. There were 12 Greek titans, 12 tribes of Israel, 12 parts of the magical breastplate of the Israelite high priest. The power of the celestial 12 carried over to the 12 apostles of Jesus, and even in our decimal system we count from 1 to 12, and only after 12 do we return, quote, 10 and 3, end quote, 13, quote, 10 and 4, end quote, and so on. Where did this powerful, decisive number 12 stem from? From the heavens. For the solar system, the 𝐷𝐵𝐵 included, in addition to all planets known to us, also the planet of Anu, the one whose symbol, a radiant celestial body, stood in the Sumerian writing for the god Anu and for, quote, divine, end quote. Quote, the 𝐓𝐘𝐒 of the supreme scepter is one of the sheep in 𝐷𝐵𝐵, end quote, explained in astronomical text. And when Marduk usurped the supremacy and replaced Anu as the god associated with this planet, the Babylonians said, quote, the planet of Marduk within 𝐷𝐵𝐵 appears, end quote. Teaching humanity the true nature of Earth and the heavens, the Nephilim informed the ancient astronomer priests not only of the planets beyond Saturn, but also of the existence of the most important planet, the one from which they came, the 12th planet.
End of Chapter 6. Thanks for listening. Please like and subscribe for more. Also, please comment sequel below if you want to hear Book 2 of the Earth Chronicles series, The Stairway to Heaven.